Hello, boys and girls. It's Mr. Landry. Today we're going to begin our study of trigonometry. Trigonometry is a Greek word, trigo meaning triangle, metric meaning measure. And basically it's the study of the right triangle. This is where we'll begin. Ratio is just a fancy word meaning fraction. So when we say ratio, we mean a fraction, one number over another. Study of trigonometry is pretty old. The Babylonians, Egyptians, the Cushites studied trig about 2,000 years before Christ. The systematic study of trig basically was with the Greeks. Hipparchus is considered the father of trigonometry. Codified a trig table, which we'll talk about later, about 200 years before Christ. The study of trig continued with Indian scholars and Islamic scholars. And then around the 12th century AD, the Europeans put this stuff together and gave Latin names to the trig functions, which they translated from the Indian and the Islamic work that had been done. So let's begin. Today we're not going to talk so much about what you can do with trigonometry, but in some of the terminology that we'll need to understand trigonometry. In the subsequent lessons, we'll start to do different types of problems. The 6 trigonometric ratios, in other words, the six fractions that can be made, have these names. Sine, which is abbreviated SIN. Even though you write SIN, you still say sine. Cosine, abbreviated COS. Tangent, abbreviated TAN. You write TAN, but you say tangent. Cosecant, abbreviated CSC. Secant, SEC. And cotangent, COT. These are what we call the 6 trigonometric ratios, meaning they are fractions of the sides of a triangle. One side of a triangle, the measure of it, let's say it's 6 inches, over another side of the triangle. Okay, that's what these are. So we're going to begin, of course, with the right triangle. That's where trigonometry begins. And we're going to start with some definitions here. Okay, so let's take a look at some triangles. Okay, here's a triangle up here. And let's say we're here at angle A. Now, if you're standing here at angle A, there are 3 sides involved in your triangle. This black line here is the hypotenuse. The hypotenuse is the side that's across from the 90-degree angle. Now, if you're at angle A, we're going to classify these other 2 sides. Notice that this blue side touches angle A. If a side touches an angle, we say that side is adjacent. ADJACENT. This side here, this blue line, is adjacent to angle A. Okay? Now, it's true the hypotenuse touches it also, but we don't consider the hypotenuse a side of the triangle. We call it the hypotenuse. Just like the ceiling is the ceiling, okay? Now, the side over here that doesn't touch angle A, okay, the red line here, is called the opposite side of angle A. That's opposite angle A. So, in terms of angle A, if you're standing at angle A, the red line here is the opposite because it does not touch angle A. The blue line is the adjacent to angle A because it touches angle A. And the hypotenuse is the hypotenuse. It's the side across from the 90-degree angle. Okay, those are how the triangle will be classified in terms of somebody at angle A. Now, let's look at the definitions of the trig functions. We have the sine. The sine of an angle is the fraction of the opposite side of the angle over the hypotenuse. Okay? And let's take a look at that in this triangle. Let's say we measured this side of the triangle with a ruler and it turned out to be 5 inches. And then we measured this side of the triangle, and it turned out to be 12 inches. Then we lost our ruler, okay? So we had to figure out the hypotenuse indirectly, meaning without a ruler, using mathematics. Well, you guys all know the Pythagorean theorem. One leg of the triangle squared plus the other leg or side of the triangle squared is always equal to the hypotenuse squared. Okay? Notice the hypotenuse always goes by itself. So 25 plus 144 equals the hypotenuse squared. 169 equals the hypotenuse squared. Added those two together. And so the hypotenuse would be equal to the square root of 169. Figuring out what we squared to get 169, which is 13. So here the hypotenuse is 13. Okay. Now let's look again at our definitions here. The sine of an angle is the opposite side of the angle over the hypotenuse. So if I want the sine of angle A, it would be the side opposite angle A. That's the side that doesn't touch angle A. That would be 5 over the hypotenuse, which is 13. That's the sine of angle A in that triangle. Okay. The cosine of angle A, well, the definition of cosine is the adjacent side of the angle over the hypotenuse. Well, adjacent to angle A is 12. Remember, adjacent means the side that touches the angle over the hypotenuse, 13. And finally, the tangent of an angle is the opposite side of that angle over the adjacent side. So the tangent of angle A is the opposite side of angle A. That's the side that doesn't touch angle A, 5, over the adjacent side, 12. There's the sine, cosine, and tangent of angle A. Okay? Now, an acronym was developed to help kids remember this. Okay? I'm sure you've seen it on textbooks and things. And the acronym is SOHCAHTOA. And that will help you remember these 3 trig ratios. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay? SOHCAHTOA will help you remember the 3 major trig ratios. Okay? Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Whenever you sit down to take a trig test, always write the word SOHCAHTOA, or the acronym SOHCAHTOA. Okay? That's the first thing you should do when you're doing your homework in trig and when you're taking a test in trig. Okay? Let's look at another example. Let's look at this triangle here. We have a right triangle, and we have angle D, E, and of course the right triangle, the right angle F. Okay? Here we're going to talk about angle E. Now, this side here is the hypotenuse. We can always spot that. It's the longest side of a right triangle. It's also opposite the right angle. Now, if you're standing here at angle E, this red line touches you. Well, then this line here would be the adjacent to angle E. If you're standing here at angle E, this side does not touch you. This would be called the opposite of angle E. And the hypotenuse is the hypotenuse. Okay? So here, if you're at angle E, the side that touches you is here, adjacent, and the side that doesn't touch angle E is over here, the opposite. Let's do the trig functions. The sine of angle E. Now remember, we now know SOHCAHTOA. Well, the sine of angle E is the opposite side that doesn't touch angle E over the adjacent. Let's give these sides some measurements. Let's say we measured this stuff with our ruler, and this side was 8, and the hypotenuse was 17. And then we lost our ruler. So we're going to find this by Pythagorean theorem. So we know one side squared plus the other side squared, which we don't know, I'll call it x, equals the hypotenuse squared. Notice the hypotenuse always goes by itself, whether you know it or you don't know it. 64 plus the other side squared is 289. Let's get the x alone. Let's subtract 64 from both sides. X squared equals 225. So x is the square root of 225, or 15. So this side here, see here, is 15. Here's angle E. Its adjacent side is 8. That means it touches the angle. Its opposite side is 15. That means it's the side that doesn't touch the angle. And the hypotenuse is the hypotenuse. So here we have our acronym SOHCAHTOA. Now we'd like the sine of angle E. Well, opposite over hypotenuse, OH. The opposite is 15, and the hypotenuse is 17. That's the sine of angle E. The cosine of angle E. Well, that's the adjacent over the hypotenuse. The adjacent, that's the side that touches, is 8, the side that touches the angle, and the hypotenuse is 17. The tangent of angle E is the tangent over here, OA, opposite over adjacent. Opposite angle E, the side that touches it, over the adjacent to angle E, the side that touches the angle. And there's your sine, cosine, and tangent of angle E. I might say, what about the other three trig functions? Cosecant, secant, and cotangent. Well, cosecant, abbreviated CSC, secant, and cotangent are called the reciprocal trig functions. Reciprocal means upside down. The cosecant is the sine upside down. So if the sine of angle E is 15 over 17, the cosecant of angle E is 17 over 15. It's the reciprocal of sine. Reciprocal means upside down. The cosine of angle E is 8 over 17. Well, the secant of angle E is the cosine upside down. So it's 17 over 8. The tangent of angle E is 15 over 8. Its upside down, or its reciprocal, is the cotangent. And that would be 8 over 15. See, these are upside down functions. They are reciprocal functions. Just memorize one. Memorize the cosecant is the sine upside down. Cosecant is the sine upside down. You're probably not going to forget the cotangent is tangent upside down. And of course, then secant would be cosine. Cosecant is the sine upside down. Okay? Just like here, we had these three here. The sine of angle A was 5 over 13. So the cosecant of angle A is 13 over 5. Cosecant is the sine upside down. Okay? Hope you got the idea with that. So now you know how to find the 6 trig functions and what opposite and adjacent mean when you're talking about a triangle. Okay? All right, let's try another. Let's say we have a triangle. Let's call it GHI. It's a right angle. Okay. We do some measurements, and this turns out to be 4 inches. And we do a measurement here, and this turns out to be 10 inches. Okay. And we don't know what this side is, but we'll find it by Pythagorean theorem. 4 squared plus the other side squared, which I don't know, is the hypotenuse squared. 16 plus x squared is 100. Let's get the x alone by bringing the 16 over to the other side. X squared equals 84. X is the square root of 84. Well, I don't know the square root of 84, so I'll just write square root of 84. It's not a perfect. It's fine. So now let's do the 6 trig functions. Let's do it for angle G. So we're going to find the sine of angle G, the cosine of angle G, and the tangent of angle G. And let's list our other 3. I always list them right next to them, the upside downs next to their other one. So cosecant of angle G is the sine upside down. The secant of angle G is the cosine upside down. And the tangent of angle G is the cotangent upside down. And that's the way when you do your homework tonight, you should list your 6 trig functions. All right, so if I'm standing here at angle G, the square root of 84 touches me. That would be the adjacent. If I'm here at angle G, the 4 is my opposite. Okay, and of course, the 10 is the hypotenuse. So the sine of angle G. Well, we know our acronym SOHCAHTOA. The sine is the opposite over the hypotenuse. 4 is the opposite over 10. The cosine of angle G is the adjacent over the hypotenuse. Adjacent, the side that touches angle G. Square root of 84 over the hypotenuse, 10. And the tangent of angle G is the opposite over the adjacent. Opposite, side that doesn't touch, 4 over the adjacent, square root of 84. Now, some people don't like to write 4 over the square root of 84. So we'll make it a decimal. Let's go to our calculator. Okay. Clear. 4 divided by the square root of 84. 0.4364. You can always make them decimals if you like. So instead of writing 4 over the square root of 84, which is fine, I made it the decimal, 0.4364. You could have done that here and here. Now, let's do the other trig functions. Cosecant is sine upside down. So if sine is 4 over 10, cosecant is 10 over 4. If cosine is square root of 84 over 10, secant is 10 over the square root of 84. And if tangent is 0.4364, well, you want to turn that upside down? Let's go to the calculator. Notice I use 4 decimal places. Let's go to the calculator. Let's put in 0.4364, and let's turn it upside down. And there's a key on the calculator that does that for you. It's the x minus 1 key. Just press x minus 1 and enter. 2.2914. Notice I use 4 decimal places. It's pretty standard to do that. So if you want to turn a number upside down on your calculator, just press the x minus 1 key. Like if you have the number 2 and you want to turn it upside down, 2, x minus 1 key, enter, 0.5. 2 is 2 over 1, and 0.5 is 1 over 2. So that key will turn things upside down for you in case you have a decimal. But fractions are fine, decimals are fine. If you do use decimals, do 4 decimal places. And don't get nervous if you get a square root. Not all right triangles are nice, perfect triples. Okay? Now, one last thing. Maybe we should stop here for today. I was going to show you, now let's show you how to do the angles. Okay? Let's go back to this triangle we have over here. I know that the sine of this angle is 5/13. I know that the sine of angle A is 5/13 in this triangle up here. Okay. Well, I could find angle A. Inside your calculator are all the sines and the angles that go with them. Now, a couple of things to make sure. Press mode on your calculator and make sure you go down 3 lines. You are in degree mode. If you're not, move over using that key, press degree and press enter. Be in degree mode when you're doing trigonometry. Okay. And now let's get out of that. Let's clear. Okay. Now, I know the sine of angle A is 5/13, but I want to find angle A. So that chart that Hipparchus made is in your calculator. It's been programmed in. So I'm going to tell the calculator what the sine is. Now, the way you do that is you press second sine. When you're telling the calculator what the sine is, you press second sine. If you're telling the calculator what the cosine is, you press second cosine. I'm going to tell the calculator that the sine of some angle is 5/13. Second sine. And then I'm going to put 5 divided by 13, close parentheses. I've told the calculator the sine. Now the calculator will tell me the angle. 23 degrees. I could have done it with cosine. Look, the cosine of the angle is 12/13. Well, let me see what the angle is. Second cosine. I'm going to tell the calculator the cosine. 12 divided by 13, close parentheses. Enter. 23 degrees, just like here. Not going to get a different answer. Okay. Let's look at one more example of that. Let's say you got a triangle. We just did 8, 15, 17. Now let's say you want to find out this angle up here. We'll call it angle E. I know that the sine of angle E is the opposite over the hypotenuse. Opposite, 15, the side that doesn't touch. Hypotenuse, 17. You want to find out what angle E is? Well, you're going to tell the calculator what the sine is. The way you tell the calculator what the sine is, you press second sine. That notifies the calculator that you are going to tell the calculator the sine. Second sine. Now let's tell the calculator that it's 15 divided by 17. And the calculator says that angle E is 62 degrees. So now you know the 6 trig functions and you know how to find an angle. Okay? You could have done it with cosine or with tangent. Second cosine, second tangent. Second cosine, you're telling the calculator what the cosine is. You want the calculator to tell you the angle. Second tangent, you're telling the calculator what the tangent is. You want the calculator to tell you the angle. Okay. We'll talk a little more about this in the next lesson. Okay. Thank you, and I'll see you soon.
Once I was 7 years old, my mama told me, go make yourself some friends or you'll be lonely. Once I was 7 years old. It was a big, big world, but we thought we were bigger. Pushing each other to the limits, we were learning quicker. By 11, smoking herb and drinking burning liquor. Never rich, so we were out to make that steady figure. Once I was 11 years old, my daddy told me, go get yourself a wife or you'll be lonely. Once I was 11 years old. I always had that dream like my daddy before me. So I started writing songs, I started writing stories. Something about that glory just always seemed to bore me. Cause only those I really love will ever really know me. Once I was 20 years old, my story got told. Before the morning sun when life was lonely. Once I was 20 years old. I only see my goals, I don't believe in failure. Cause I know the smallest voices, they can make it major. I got my boys with me, at least those in favor. And if we don't meet before I leave, I hope I